Putting terms in order. A mathematical expression will often contain a number of terms. As you'll recall, the terms of an expression are separated by either addition or subtraction. While the value of an expression is independent of the order of the terms, it'll help a lot to put them in a specific order. It's good practice to order the terms by the degree of one of the variables. The degree of a variable is the value of the exponent in a term. So here we have an expression 5x cubed minus 4x to the fourth plus 2 minus 3x. So here we can look at the value of the exponent. So the degree of 5x cubed is 3 since the exponent is 3. Here, negative x to the fourth, the degree is 4 since the exponent is 4. 2 is a constant which always has a degree of 0. Think if you do not see any variable, there's 0 of the variable. And negative 3x, if you don't see the exponent but there's still a variable, it's an imaginary 1, so the degree is 1. For instance, here the expression below is not ordered. So the expression from before, 5x to the third minus x to the fourth plus 2 minus 3x is not in order. This is mathematically correct, but will lead to some mistakes later in this course if you're not careful. It's better to write the final expression with the highest degree terms on the left, with each term to the right being next highest. So you always want the highest degree first. In this case, our highest degree is a 4. So that is going to be written first. Negative x to the fourth, followed by your degree of 3, then 1, and then 0. Think of this like x to the 0. This will make it easier to keep track of these terms when we do polynomials and algebraic functions later on. If there are 2 or more variables, we will have to choose one of them for this purpose of ordering. Here's an example of an expression with more than one variable. We have x's and y's. So we have x to the third, x squared, and we have y squared, y, and y to the third. So we can choose to put the terms in order using either x or y. It doesn't matter. They would both work. But since x comes first in the alphabet, it comes before y, I'll order the terms using x first. So here, x, not black, we used black for x, so I'll keep to be consistent. So here we have x to the third was the highest, so that comes first, followed by x squared, then x to the first, followed by the term that doesn't have any x at all. So it ends up being ordered x to the third plus 7x squared y minus 9x to the first y squared minus y to the third. Notice that the degree of the variables y are now ascending from left to right, which is just a coincidence. This won't always happen, but sometimes it will. It's kind of cool, the different patterns that come out when you reorder the expression. Now let's rearrange the terms in descending order using the powers of y. Remember, your powers of y was y squared, y, and y to the third. So now the third is first, followed by squared to the first, and then the term that does not have the y at all. After this rearrangement, the degrees of the variable x also ascend from left to right too, and again, that won't always happen, but just a different pattern coming out. And both of these answers work and are correct. Let's try one more example. Here we have 3x to the third minus x to the fourth y squared plus 9 minus 3x y squared. Since there are more terms in x than y, I'll order by using x. So here we have x to the third with a degree of 3, x to the fourth, a degree of 4, and x, which is a degree of 1. So we'll put the degree of 4 first, so negative x to the fourth y squared. Then we'll have our degree of 3, 3x to the third. Our degree of 1, And finally, our degree that is 0, that's a constant. So this will make it easier to keep track of these terms when we do polynomials and algebraic functions. Again, just an easier way of seeing the expression, and it keeps us nice and organized.